First up, I'm going to show you how to use solver. So in order to find the solve function, you need to hit F2 right here. That'll pull down the algebra submenu. Now click enter, as solve is the first function on the list. Now that you can see solve is inputted into my little bar at the bottom here, I can type in whatever I want. So I'm going to type in something simple, x squared minus 4. And it says too few arguments. Now what this means is that I haven't set it equal to something. So equals 0. And again, too few arguments. Make sure that when you use solver, you always have an equation equal to something, comma, the variable you are solving for. This is how to solve a definite integral on the TI-89 calculator. So, in order to actually solve an integral, you first have to use the integrate function. Now, if you just type in a regular old function like x squared, and then you have it integrate for x, it's going to give you the regular old standard integral. However, what if you want to define it between a certain region, as in a definite integral? What you're just going to do is you're going to throw on a couple commas with some bounds. I just chose the bounds of 0 and 2. Hit enter, and you've got it. And it gives me x is plus or minus 2. But what if I give it something that's impossible, like x squared plus 4 equals 0? It'll just tell me false, meaning that the equation I have entered can never equal 0. As you can see, I entered a lot of numbers into my TI-89 and got out something I deem important, the number 1. I want to store this value for later, so what I do is I highlight the number 1, and I make sure to delete any periods or commas as long as they're not a decimal place. So, there we go. Next, I hit the STO key, which is just above the power key, and it gives me this nice little arrow sign, which means that I am ready to store the value 1 as a variable. I'm going to call my variable xyz, and bam! The number 1 is now stored as xyz. I can type in xyz, and I still get 1. No matter how many times I enter xyz, I will always get the value 1. What if I no longer deem the value 1 important? Well, I hit the second key, and then the minus sign, which brings up varlink. Now what I do is I scroll down to xyz, highlight it, click F1, click enter, and then enter again. Now that I go back here, I type in xyz and it equals itself, which means that xyz no longer stores the value 1. Now I'm going to teach you how to graph a piecewise function. First, I'm going to hit catalog. Then, I'm going to hit the period, so the W section pops up. When I'm highlighting when, I'm going to click enter. Next, I'm going to give it some arbitrary value, which if x is less than, it'll graph one function, and if x is greater than, it'll graph a different function. I'm going to use x is less than or equal to 2, but where's the less than or equal to sign? Hit second, and then 5. Hit 8, and then as you'll see, 4 is less than or equal to. I hit 4, and now the less than or equal to sign has popped up. Next, I'm going to type in 2, comma, and now I'm going to type in an arbitrary function. So x squared minus 2. Then make sure you enter a comma. X plus 1. Make sure you close the parentheses or it will not graph. Hit enter. Hit graph. And as you can see, it does change. Now I'm going to show you how to change line style on the TI-89 calculator. Suppose you have multiple functions and you can't exactly tell which one is which. This is where changing your line style would come in handy. Now in order to change your line style, you're going to hit the second key, then F1. which will pull up the F6 menu. Now there's 8 options to choose from. However, the latter two, above and below, will shade either above the line or below the line. This is helpful for representing inequalities. I'm just going to change my Y1 to dots. Then I'm going to hit the diamond and then F3 to change the graphs. And it's a little hard to tell on the camera, however, it actually changes to a dashed line. As you can see here, I have 3 functions, and only one of them has a checkpoint next to it. That means that only that function is going to be graphed. Let me show you. And as you can see, only sine of x was graphed. Now, I want to turn sine of x off and turn a different function on. So I hit F4, and that removes the check mark from in front of sine. I'm going to go up to x squared and hit F4 again. That'll select x squared and give it a check mark, which means that when I graph now, only x squared should be graphed. Now I'm going to show you how the different zooms work. To access the zoom menu, hit F2, and you'll see that about 9 or 10 zooms pop up. Some of these are really useful, and others of them don't make complete sense. Zoom box allows you to set points for a box, and the TI-89 graphing screen will automatically zoom to fill that up. You cannot set 2 of the same points as the same point, because then the TI-89 will throw up an error message and you will not zoom. So next are zoom in and zoom out. They're inverses of each other. They allow you to set a new center and zoom in or zoom out relative to that point. Now, this is really interesting. Zoom SQR allows you to zoom a function in or out in order to fit it upon the graph of y equals square root of x. Zoom trig is another very useful one that allows the zoom box to be zoomed to fit a trigonometric function from negative pi to pi. Now I'm going to quickly show you how to graph a function with its derivative. So what I do is I'm going to hit second and then 5, which will bring up the math menu. I'm going to scroll down to calculus, hit the side arrow key, and then hit differentiate. Next I'm going to go back into varlink, so second and the minus sign, and scroll down to y1. Type in x, comma x, and hit enter. Next, I'm going to tell it to graph. And as you can see, I have sine and cosine graphed on here. I am now going to show you a program that allows us to solve for area underneath the curve using Riemann Sums and the rectangle and trapezoidal approximation methods. This program is accessed underneath the varlink, and it's called Riemann. Now, unlike other programs where I might enter something within the parentheses, I'm just going to close the parentheses and hit enter. Now a separate screen will pop up and it prompts me to type in a function in terms of x. Make sure that is in terms of x because the program will not understand otherwise. I'm just going to type in my standard program, or my standard function, x squared minus 4, give it an interval of 0 to 2, and enter in 4 rectangles. Now this program allows me to solve from either the left, right, midpoint rectangular methods, or trapezoidal. I can also solve for all of them. So I'm going to hit 5. It's going to give them to me on separate screens in order of how they showed up on that menu. So left sum, right sum, midpoint, trapezoidal, and then I hit enter one more time, it'll pop up a little box where I can do it again, or I can quit. I choose to quit. Now, in order to actually fully quit the program, you need to hit escape. And as you can see, it says done. Now, I'm going to show you a program called slopes. This allows us to generate slope fields on the TI-89 calculator when you enter in a derivative. So, in order to access this program, I go through varlink. I'm going to highlight the program and then click enter. Now, if you enter anything within the parentheses, it gives you the error there's too many arguments. So make sure you don't enter anything within the parentheses, because you'll have to delete it and retype it here. This is where you're going to enter your derivative. I'm going to enter in x squared divided by y squared. Now it uses the actual graphing table in order to plot the slope fields, so please make sure you don't already have a function graphed over it. Otherwise it'll graph that function and then your slope field. This is actually quite useful, however, when you want to see if a given function has the derivative that you entered in order to generate the slope field. However, if you enter something else in, it can be quite confusing. As you can see, it's almost finished. And now let's move on to Riemann's sums. Hey everyone, thanks for watching, and I hope you finally learned how to use all that cool shenaniganery on your TI-89.